Let's dive right into this explainer. Today, we're looking at NSAuditor AI Enterprise 0.33.1. We're going to break down exactly how this platform solves a massive headache for security engineers, generating cryptographically verifiable pre-audit evidence and doing it natively right on your own infrastructure.
Look, every compliance audit starts the exact same way. Someone asks you to prove how your cloud is configured, and you have to go collecting. You're grabbing screenshots, console exports, or maybe a spreadsheet somebody swears is current. Then the assessor drops the hammer with the one unanswerable question that none of that evidence survives. How do I know this wasn't edited after you exported it? NSAuditor AI Enterprise answers that question directly with just one read-only scan. It runs agentlessly on your own infrastructure using strictly read-only credentials. Across AWS, Azure, and Google Cloud, just one single command evaluates exactly 1,608 controls. And that single scan doesn't just spit out raw data. It returns 7 distinct, genuine auditor-shaped reports. We're talking SOC 2, HIPAA, NIST CSF 2.0, PCI DSS, ISO 27001, CIS V8, and the GDPR Article 32 infrastructure substrate. It's not one report relabeled 7 times. These are 7 actual reports.
Moving on to honest coverage and scope, this is where we look at how declaring boundaries builds trust.
Here's the part most tools leave out. Every report tells you exactly what it did not assess and why. Take a look at the SOC 2 matrix. You'll see 10 covered, 4 partial, and 37 out of scope out of 51 criteria. It's stated against the full universe, so nobody has to work out the denominator.
To give you some concrete examples of genuine out-of-scope reasoning, a configuration scan simply cannot evidence physical access to a data center, board oversight, or security awareness training. So the report honestly says so. It directs the auditor to the keycard log or the HR record instead, because if an assessor finds one silent gap, they stop trusting the whole document. Declaring the boundary is what makes the covered part worth reading.
Next up is provable evidence integrity, focusing on cryptographic proof of the data gathered.
Every single artifact ships with a SHA-256 chain of custody sidecar that is always on. This sidecar means basic integrity can be verified instantly and completely offline. You simply run a standard checksum command against the file, and it passes. Now, for third-party non-repudiation, RFC 3161 trusted timestamping is available as an opt-in capability. Let me repeat, it is strictly opt-in. It has no default, ever. You have to explicitly point to a timestamp authority URL that you choose. When you do, it equips every artifact in the pack with a trusted timestamp sidecar your auditor can verify entirely offline with stock OpenSSL. We test this in both directions. When you test the published binaries against a real public authority, the system successfully returns a crisp verification OK. But if you append just a single byte to that report, the exact same check returns verification failed. That failure is the point. It is what turns the claim that a command ran into cryptographic proof of these exact bytes at that exact moment. Bringing us to where your data goes. Let's talk telemetry and moving past unprovable claims.
We used to say nothing leaves your network, but a claim like that is falsified by a single omission. So we replaced it with something you can actually audit. The product now publishes a register of exactly 17 outbound paths. Each one enumerates what triggers it, whether it is on by default, what class of data leaves, and how to switch it off. It's generated directly from the code, so the document literally cannot drift from the product.
This gives you absolute assurance. No scan data, no cloud API credential, and no evidence artifact is ever transmitted to NSAuditor. Ultimately, your evidence is only worth what an outsider can check about it. With these verifiable sidecars, now they can check it without you. So, when your next audit rolls around, will you be scrambling for questionable screenshots or handing over cryptographically bulletproof evidence?